Well, that's a very crude Earth. It might not write on there because I just cleaned it, so I should really wait. But even still, crude depiction of the Earth, yes?
Yeah.
And if we just draw in some random land masses, it doesn't really matter terribly much if it's going to. Still seeing that, aren't you?
Yeah. I'm seeing something, not much.
So what's the deepest part of the ocean? Is Mariana Trench, isn't it?
Yeah, that's the deepest we know, isn't it?
The deepest known, yeah? And I mean, that much of the ocean hasn't really been mapped, has it?
No.
So do you think that there's ever possibly an event that could happen on the Earth that could make all landmass disappear? You know Earth's a water world, although it seems like it's only a very small skin. Yeah, how am I going to explain this? Right. Anyway, right now I'm just clearing out the clutter. Making room for something really awesome. So, let's say we got something that is full to about this level, yeah?
Yeah.
I would say a glass of water, yes?
Mm-hmm.
Now, if I drop in a few cubes, the water level increases, yeah?
Yeah.
And the more mass or matter I add into it, the more deeper the water gets.
Mm-hmm.
Same is true if I remove some stuff, the shallower the water will become. If I take these out,
Yeah.
it'll drop down. So if we take the deepest part of the ocean,
Mm-hmm.
let's say for argument's sake,
Yeah.
and if a volcano decides to erupt under the ocean, you are adding mass to the ocean at a very deep part.
Yeah.
This will cause the ocean levels to rise.
Yeah.
And in some cases it can rise rapidly.
Mm-hmm.
It will also expose other land masses, although not much. It would be very shallow waters over the land mass, don't get me wrong, but still. If we were to do a calculation, the highest peaks on the land mass, yes?
Yeah.
We'd say that would be a mountain. And even then, could you imagine that? If there are multiple volcanoes, or if we take the fault lines, nope, I think that pen's now run its course. If we take the fault lines,
Yeah.
and if this was to erupt, so, you know, in America they have that Yellowstone.
Yeah.
Could you imagine a Yellowstone under the ocean? And we'll say, well, it's held on by the heavy water, which is putting pressure down, so it's not going to do anything, and this, that, and the other. And we often think that. Has there ever been an event in history? You see, that's the lack on this Earth. You see, we see lots of volcanoes make landmass. We understand that, but when did they make the landmass? How did they make the landmass? We know that hydrothermal vents are continuously running. Underwater volcanoes, although you can't see it, that's the difference with that one. You can thermally image it, yeah, don't get me wrong, but an event like this that pushes out a large amount of matter into the ocean is going to displace that water.
Mm-hmm.
And it's going to take a little bit of time to rise, but it will begin to rise everywhere and evenly. And even some of the highest land masses will become just very shallow peaks.
Mm-hmm.
And then you'll be waiting on another event, because usually when you have a volcano event or a plate, you either get them pushed down, cause a valley, or you get them to rise up, which will cause a peak, yes?
Yeah. Mm-hmm.
Or what about if they split open and push out a load of mass, which you could then say would make a valley or a peak? No. What about if it peaks up and separates and produces a load of lava at a very rapid pace? And then depending on how far on the fault line that it would do that.
Yeah.
And then where does it do it? That's another question. And then most islands gone. Near enough all land masses will be changed in one way or another. Once that happens, the crust is still very weak. And it's possible that then it could happen again and then a new landmass appears. So you take Hawaii as one at the moment, isn't it?
Yeah.
But again, it's the water that shifts. Although a very small skin, don't underestimate it. But how many times throughout history has this event happened? Once? Never? Multiple times? Is it a cycle? You know, you ask all of these sort of questions and you kind of get some places. And after all, they say that we come from the ocean, right? And life comes from the ocean, yeah?
Yeah.
Well, if that's true, then that's a very interesting thing. There's one thing that happens in these events that impacts life the most, which is there's the lack of fresh water. Well, there is fresh water in the ocean, don't get me wrong, because it will act as the skin. But without landmass, you don't have rivers, and therefore you don't have you still have the purification process, but nothing that will pull this fresh water. Well, small peaks of a mountain are going to hold a little bit, but even still. And then it changes your weather pattern. The whole weather shifts across the planet. So you've got you've got weather, you have rising water, and a loss of landmass. So the loss of fresh water. And that causes mass extinction events quite a lot of the way around. Especially for cold-blooded creatures. They'll lose a lot of heat. It's a bit like hypothermia, really, isn't it? I think they're more susceptible to it, aren't they? Yeah, cold-blooded creatures are more susceptible to hypothermia. Warm-blooded too, don't get me wrong, but... Cool. What a change. And it also changes the gases in the atmosphere. Because the lack of trees, higher salt content, it knocks out fungi. Let's be realistic on that. And then you've got all of these other changes that happen. And, well, for humans, it would be farming would be completely gone. Livestock, loss. I mean, this is a mass extinction event if you're not prepared for it. And it's unlikely that it's going to happen, but even still, it's a possibility. And again, that all depends on predict where a volcano is going to rise up. Because most of them we say that they're extinct and dormant and all the rest of it. Well, at the end of the day, it depends on what sort of cycles happen that trigger this off. We know land masses move, and we also know that seas move, but it becomes very hard to model as to how they move. Technically, they don't move. Not really, no. You could understand that all of the landmass you see now, pockets of volcanoes that were around, these were under the ocean and all of a sudden started erupting. Now, is it simultaneously? That's another question in time. Not exactly. And then these new landmasses rise up. And then you'll understand that that displaces the water, which then it has to go somewhere to the old land masses, which then become waterlogged in ocean water. It's a very cold and chaotic event, but even still. And usually when you find that one fault line goes, another one goes, another one goes, another one goes. So again, it's fast in the grand scheme of things, don't get me wrong, but again, it's a very slow process for anything that's caught off guard on these situations. Yeah. Very interesting. And then perhaps with the change of gases, you then might get an event that triggers off to cause mass freezing. No, we understand that. On Mars, was it got carbon on it?
Yeah.
You think that without a core, that's still pretty warm, isn't it?
Yeah.
Was it 14 degrees on average?
Is it?
Or is that the wind speed? Could be. It's still very warm.
Mm-hmm.
It's very warm for considering it has no internal heat source. Incredibly warm. And because of its much further away from the sun.
Yeah.
So, well, it's getting its heat from somewhere.
Mm-hmm.
So, again, if Earth is a little bit more, but it's more closer to the star, but yet we have an interior core, Mars doesn't. And it's incredibly warm, it's smaller, it's further away. Just doesn't make a lot of sense, that's all to me. It seems incredibly warm. Earth then is, in comparison, is a hot ball.
Mm-hmm.
But again, we do have a core, and that heat's got to go somewhere. So yeah, interesting event, that one. So I just wanted to touch upon it, just because I was thinking about it, and yeah, just one of those ones I was playing around with, neither here nor there, but still. There's not a lot you can do about an event like that. You can't stop it. You can't exactly slow it down, and you can't make it go away. You see, water is a funny thing, and it all depends on how mass enters. You know, quite rightly so. If this explodes up and it creates a crater underneath, then the water is going to rush into that area. Sure, don't get me wrong on that. But it's got somewhere to go. If it pushes up, if Mariana Trench, rather than being downwards, begins to push upwards, this is going to move a lot of water. And if, depending on what's below it, does not contain water, or it creates a pocket, then that water volume is going to increase everywhere. But again, and that would probably erode quite a lot. It would come inland, would be a bit more smaller, I would say, in that.
Mm-hmm.
So you'll lose coastal regions very quickly.
Yeah.
But in an event like this, that's immediate impact. Well, give or take. It will be a flood that comes but never recedes.
Yeah.
And what makes it worse, and a hell of a lot worse, but also a good thing in the long run, is that once you've got ocean water over your landmass, it's very quick to start eroding it. And that's an interesting phenomenon. Once the water is on, it begins. Well, it does two things. It starts eroding, and it also flattens, especially if you've got a lot of clay pockets, which there is, because we take Britain, for example, the Mesolithic period, and you go down and you take out cores. You see all of that very less sedimenty sort of, I don't know, it's not really clay, it's not got any sand in it, it's vegetation from the Mesolithic period. Could you imagine a large amount of ocean pressing down on that? What do you think it's going to do to that layer?
Squash it.
Squash it. Into what?
I don't know, into something flat.
Yes, something flat, and perhaps later on, that's going to turn into coal. It's going to squish that into coal. It's going to have the right amount of pressure. Then it depends on whether it's close to a fault line or not. Who knows? Where it gets nice and warm and a hydrothermal vent comes through. Very interesting. And again, this erosion plus flattening plus weight, we often forget, like I said, if you could measure the water on the Earth and what pressure that is, that's an incredible amount. Yeah, it will make short work of any landmass, and it will begin sanding down the edges, so to speak, because it's technically moving sand with it as well, and sediment. And this is very abrasive. Sandpaper is very effective. So yeah, again, it's going to make a lot of stuff from this, and you never know, future generations, whatever life forms they may be, will start digging that out. And along with anything else that we've thrown into the ground, well, we know we've got a lot of methane, tons, when we put things in landfill. It generates an awful amount of methane. Crush that into some of this, and a little bit of waste over here and a little bit of that. You displace an awful lot of humans with this, and again, that's many if they survive. It's a weird thing, isn't it?
Yeah, it is.
Can you imagine that? It knocking out all landmass known? The caps too. So if they're sitting on any landmass, they will be submerged as well. And then they are... those ones would be more quicker to erode away because the seas are rougher. And without this landmass temporarily, until volcanoes... Again, volcanoes are very quick. But even still, for a human standpoint, you know... Remember, have patience. You know, you love this word. Until put to the test. You know, you see, that type of patience. But yeah, without landmass, the problem is with the ocean is it gets moving with nothing to break it, nothing to slow it down. It will just get going. And again, any land that does rise in that is going to take a battering until more appears. It's good because it grinds things down. Cool. And then do you reckon it changes the gases on your planet? Well, yes, it definitely does. Depending on what bellowing out of that. We often think of the fumes in volcanoes as a very interesting thing. Well, without nature and much of it, this is an extinction event. End. Game over. Life will begin to maneuver again. And again, sort of animals, marine life. It's already in the H2O anyway. It would take a lot of volcano activity to get that shit fizzing. Without nature, because it will be displaced, and everything else will be displaced.
Yeah.
And volcanoes constantly churning up this gas, noxious gas. Well, it's enough to keep land, ocean creatures going.
Yeah.
But eventually it will turn into carbon, high carbon content, which paves the way for any trees, that's for sure. Always wondered why they close up in water. Wondered that. You know, some of them, and they float, and they just got to wait for the right time. Always wondered what they kept that for, the way they... And even if you submerge the ground, these things float. And what's more, if you test these in salt before planting them, might they know that? And take them out of that and then throw them outside, and then they begin growing. It's quite an interesting thing, that is. It's like they know when times are right. So it's quite fascinating. And again, coconut is another one that will probably survive, and heath and very salty areas, but still. And what's great about it is it gives nature a good start, actually, to be fair, because soil is a waste product. Soil is a very bad product. When nature begins to start again, do you know how rapid it expands when it does find land? It's very quick, because it works on hydroponics. Which is quite fascinating, to be honest. Hydroponics, you get a lot more of an abundant crop and yield, and there's good reason for it. It's no coincidence that when you grow things hydroponically, especially when it comes to nature, how bigger the crop is, how bigger the fruit is, and therefore how many seeds you get. And therefore it begins to guarantee this fast spread. It almost activates in rapid growth. It tries to get as much as it possibly can going. And then it begins to spread again, and then again it begins to even the gases. That's if. And it's a big if. Because back then there was more widespread nature. Now there's less. And you often think that life tries to dominate things for a reason. And is it the reason because it just wants to take over everything, or is it because it knows something and has been around a lot longer? Or when we think about it, when we look at nature, we think, that was around when the dinosaurs were walking about. Do you understand? That's a long time to be in existence. And again, when was it before then?
Yeah.
That's a big question mark. That would be something. Well, we got this, we got that, we got coal. So we know it's been around for a very long time.
before then, yeah.
Then when is the question, the oceans begin to be displaced,
Yeah.
which then displaces life. It's brutal. And it unearths, and let's say humans were able to do something about their fate. And when this event happens, and let's say if other landmass begins to A, either push up, or B, it displaces the water in such a way that the landmasses that are now here are then covered. It's very unlikely, but let's just say after time, these other landmasses begin to push up. And then when you start to dig down, you begin to find more tree cores. You couldn't get there because they're below the ocean, let's say now, in a really deep area. So we take Mariana Trench. What if that was a valley at one point? A bit like Grand Canyon. And people and such things and nature were living there. And some of this stuff, we unearth a lot of coal. You know, that would give you a good indication. And if you took some core samples in these regions, and again, if it was unearthed that they managed to carve into stone or anything, I mean, that would be quite an interesting thing as to how long their nature has really been around for. And then it makes sense to its behavior. Never for no reason. Why it wants to dominate everything? Why it's trying to conquer the oceans? And again, yeah, it makes sense for if the planet gets hit by a meteorite, pieces go everywhere. Yeah, that makes sense. That really makes sense. How rapid it is, and why it activates faster in hydroponics. Also, hermaphrodite. Now, I mean, if you believe it, that's up to you. Most of the sayings I was always told that hermy plants can't sex themselves. Yeah, like reproduce off of themselves. Right? Okay, I'm gonna tell you. Tried this as an experiment. That saying is a whole load of bullshit. They can and do. And then they say that hermy plants, that if they do that, it depends where you go, right? Will always have hermy seeds. No, not true. If you work with this process long enough, you begin to find out that it has a lot of hermies and a few male and females variable. And again, these ones then produce quite a few hermies, but a little bit more male and more female. And a little bit more, and a little bit more, and a little bit more, until you then have variable, then becomes the hermaphrodite plants. One particular plant is enough to create one seed of hermy. And again, why does it do this? Why does it... Well, it triggers that. Hermes are guaranteed that in this new pollen environment, it would make more sense that you know how to give yourself this ingredient. I'm still waiting for another particular plant to turn hermy, to be honest, and I'm willing to bet that it will, eventually. And if it does, it will then begin to... And I wonder, that will be a very strange thing then. So that particular plant is a hell of a project right now. And yeah, so again, very interesting as to why it does that. Plus the hydroponics. Factor that into hermy. Factor that into, you know, male and female, there will be. That's a rapid growth, which doesn't make sense for it to do that. So therefore, its sociology is no soil. So, you know, it's making do with a bad situation being all of this soil. It's a terrible thing, especially to plants. And it makes do with it, but it's reading the soil. Often we look at trees and we think, you know, well, nature, and we think, it's just one-sided. It's not. It's duality in itself, and the trunk is the middle, so you could say third, triality. But it's reading the atmosphere, the pressure, the conditions. And again, it loves carbon. I wouldn't say love it, but prefers it. And volcanoes seem to produce an awful lot of stuff that nature loves. Notice this. After a forest fire, after a few forest fires, trees don't grow. Ask Scotland, they'll tell you. After a few fires, the trees are extremely, incredibly slow growing. It almost is like nigh on impossible.
Yeah.
Now, there's a lot of soil there, a lot of waste product. So after a few forest fires, that rapid growth no longer works. After a volcano, shit me, have you seen how quick it is?
Yeah.
How green the vegetation is? Do you see how well the roots form? You would think that that would be more noxious and toxic for them. Yes, right at the mouth of a volcano, don't get me wrong, certain sulfurs and stuff. So they're quite far away from that. Gee me, that's incredible. And how green and thick, and because if I ever was going to look at plants and think which one's got no imperfections, it's these ones. When you look at it, you're like, bloody hell. The volcano erupted here, but this is all... And then repeated eruptions, and it just keeps coming back each time, more vicious than before. And again, and that goes to show you something, doesn't it? That's more of a hydroponic activity, that is, and they have crazy amount of root systems, which again is interesting. Are roots designed to grab into soil, or are roots better at grabbing into volcanicity? And again, the way the roots start off very thin, it acts like lightning or freeze thaw. The root, very small, grows into a crevice of a piece of rock. And then it begins to get bigger and bigger and bigger, and it busts open these rocks, which is fascinating. The weather does the same thing. When you get water in and ice, and you would think that ice is quite brittle, wouldn't you?
Yeah.
I mean, if you dropped an ice cube on a rock, the ice cube's going to break. And then if you take the rock and drop it on the ice cube gone. But yet, when you utilize ice in the correct way and find that rock to break it and drop in a bit of water into a crack and a crevice, and it freezes over time, you then understand that ice is weak, but it's also very strong.
Yeah.
Depends on how you use it. Wow, that's a very interesting thing. But also roots do the same thing. I was lucky enough to see this on certain things, and there are these old buildings that are being reclaimed by forest. And some of these trees, man, how the hell they're even growing in these areas, I don't even know. That's an incredible thing to see. A tree growing from the top of a wall. It just takes a seed to get lucky.
Yeah.
And the way the roots just grab this thing, it's incredibly strong. It's really bolted down to it. But the most fascinating thing is the way it begins over the years. Now, I wasn't there to watch this in full. You know, I'd have to be there at like every moment of every day. And there again, I probably wouldn't see it. But because I kept going back to these areas over years, sometimes it would be a few years later, and then go back and be in the area. I remember that. And each time you go back, you're noticing that the roots are finding their way through and are stretching the and buckling the brick material. I don't know what it's called. It might be concrete. I'm not really sure. That's pretty impressive, right? That it's got patience to really bring down a building, right? Yeah, you've seen some of these in the...
Yeah, my grandma had one on her balcony. She had small balcony, and from the side was growing this little silver birch.
Yeah?
Yeah, for years it was there.
And when the roots really start to get in there, they really... Well, you've seen what they do to paths.
Yeah.
Yeah. All they need is a tiny hair. And, you know, it's almost like a hair follicle. But when they begin to grow out and stretch into these areas, they then begin to expand.
Yeah.
But in the same design that you would understand, looking at water through a crack reminds me of a lightning strike. And again, a lightning strike the same way. I mean, it can really shatter things. It gets into the veins of the tree, if you like, and then splits it. It's impressive, isn't it? Don't you think? nature has figured certain things out, but why? Why do you need to do that? You see, again, if you're on quite a rocky place, I mean, it makes good anchor points as well, doesn't it?
Yeah.
If you think about it, that's quite the crikey hell. You really struggle to pull it out. And another great one for doing is, you know, the cracks in between patio.
Yeah.
Did you try to pull on some of that stuff? Come on. Did you notice that is in there?
Yeah.
You go and take a piece off the lawn and it's like, oh my days, I can lift this shit till the cows come home.
Yeah.
But as soon as it gets in between a piece of rock, you notice how crazy the roots are,
Yeah.
how they spread.
Yeah.
But they don't opt for the soil. They opt to stay in that area. Leave it long enough and it will begin to push away if it's got room to maneuver, right? And if humans haven't put stuff around and it's just two slabs together, the roots will begin to push that apart. And that's fascinating that they're just roots, right?
Yeah.
But again, roots are like plaits. Strong. Your hair is incredibly strong. You can pull things with it. But again, that is amazing. That's hydroponic, by the way. And you notice you get the best fucking weeds ever growing in between crevices of what do you call it, patios and stuff, and how strong it is. And my word, very tenacious, right? It relies on roots, and you'll understand that is a hell of an anchor point in between there. Really, really cracks in there. And yeah, if you think about it, on a windy planet, that would take a lot. Imagine if that were a tree that's got a lot of anchor points. And again, these roots act like, you know, when you get pulling. This is where I got the understanding of, you know, on the moon, to try and dig on the moon, it's nigh on impossible. But you can put anchor points in, tighten these up, and what have you made? Mass. So essentially, are trees actually pulling down on the ground? And if they are they creating more mass? Which is an interesting thing, right? It sounds so barbaric, but think about it. If it's really windy, do they actually grab their anchors and push down more when it's windy? And again, how would you ever know if they were or were not doing that? See, that'd be a hard thing to try and prove either or, yes? But I think they do it, and to get that understanding, to be able to dig, and you put anchor points down on the moon, and then begin to ratchet these. This is the human way, I guess, and it pulls you down. You can now mimic Earth's gravity, and I've used this on the Earth as well. If I need to move a very big object or I've got a lot to dig, and there's a lot of roots there and a way to go about it. I just wonder if they ever pull down, a bit like a clam. They sort of anchor in, and this is what they're using that for. And I think that's why they prefer rock, to be honest. So they have better anchor points. And again, if you've got a planet where you've lost your landmass, and there are a few bits of landmass sticking out, and you've anchored into these points, the winds are going to be ferocious. And your roots alone are probably not going to be enough. You're going to need some objects to have anchor points into, and more than that, you're going to need to either not go in the swelling in a certain way. So if you understand it, if we draw a root like this, it seems like it's great, yeah. But if it was trapped underneath some rocks here, it would be better for the plant to swell more here. Because the force, it's going to take a lot of force for that to bust that, especially if it grows in between.
I can't see them, but
yeah, I know, because my pens are terrible, and it's not because I got the solution on there.
Because it's dark.
So rather than doing it that way with the root, and let's say you got a rock here and a rock here, and it's gone through. If it swells up at the end, that's a hell of an anchor point. But I just wonder if it dried its own root. It's living, of course, and life means intelligence. If it was to, so when a wet root, they're quite long, but when they dry, slightly dry, they contract.
Yeah.
Well, if it's wet here, moist, I should say, but if the tree itself starts draining from this very quickly, isn't it going to pull that towards it? You think about it, when it dries, it slightly shrinks. Therefore, that acts as like a sort of a pull down. And I wonder if in strong winds, it releases a hormone that tells it to draw moisture from the roots. Interesting.
Okay.
And then it might be able to cope with a bit more wind ratio, especially when landmass disappears. And I think this has happened a lot on this planet. Earth is a water world. Essentially, it's a water world, if not for volcanoes. But also volcanoes are a double-edged sword. Everything is. So where volcanoes start putting the mass into the ocean at certain areas, this rises the ocean levels. And again, it depends on how much mass it's put in, and if it's a plate that's gone, and it starts pumping out an awful lot of lava, that's going to destroy land mass. And then what does it rise it by 100 meters? Water's got to go somewhere. You're looking at an event that could happen, and it could cause an eruption, especially if there's quite a few. I know there's a few under the certain parts of the ocean where they all line up, isn't there?
Yeah.
It's also known as it's a temperamental fault line. I can't remember what it's called now. Do you know that? What it's called? But you know the one I'm on about.
Yeah.
If they pop and leak lava sideways into the depths of the ocean, the ocean water could rise even up to 200 meters. That's all round.
Yeah. Everywhere. Yeah.
So if you are 200 meters above sea level, and to make that situation water is not very plus with this minute brings it really is, when you action of it on people that they couple with dry still are in the ocean not the whole time. These are a bit more smashy. You are being sandblasted. That's why your skin feels smooth. It's nothing to do with the salt. Ah, that helps. But it's the miniature sandblasting that it's doing to you. This removes your dead skin. And therefore, that abrasiveness is like exfoliating. Yeah. That's why I find it strange that Dove used to do that stuff with the microbeads in it. You put a bit of sand in there, in your soap. It does the exact same thing, and what's more, it's great when it goes into the rivers or wherever it lands, you know, where they say that it breaks things up or whatever else. And you know what else is it doubles up as? Great for removing limescale in your sewer pipes. Yeah, of course. Yeah, it hits into it. Okay, perhaps one bag of sand XYZ is not great, but every now and then a few drops going in, it'll sort of sandblast, yeah. Depending on the force of it. Yeah, it's interesting, isn't it? All of this sort of stuff. But yeah, and imagine that across your landmass. And again, that sand churning up in that soil is very soft. The landmass that we have is incredibly soft. Oh yeah. And when you think about it, the sand and the pebbles hitting it and the ocean moving back and forth, the landmass that we have is susceptible to erosion faster because of how soft it is. You know, and until it's thrown a layer of sand over it, you know, that's going to be quite chocker. It's going to be able to erode it really easy. Hot knife in ice cream. No. Butter. Butter at room temperature with a hot knife. It's more like that. Well, that was easy. Well, because it is. And this doubles up as well because it adds a lot of nutrients into the ocean, so life then begins to evolve. More info, more this, more that. It also pollutes it in certain areas, of course it always does, but still, yeah, give and take. So yeah, events like this, never a good day for humans unprepared. Could you imagine that? Within, 24 hours of this blowing, you've got a lot of flood water coming in. But it's incredibly salty. Never mind with the amount of backage from sewer you have as well.
Yeah.
And yeah, it doesn't go away. And anything that's swept up in that 24 hours, and the next thing you're going to notice is the winds are going to increase. Yeah, the winds are going to be a lot more ferocious, and anything that wasn't submerged is going to be battered by big waves. And again, it depends on the objects that you're standing on. How susceptible are these to crumble? Are we standing on rock, or are we standing on soft? And even if you are, that erosion underneath is going to cause that to alter, tilt, tip, crumble. Ah, yes, it's not just meteorites and stuff. Yeah, problematic. Water worlds are very problematic. They're good, but it's a double-edged sword. It's a bit like the star. The whole universe is double-edged. It's lovely in the beginning, isn't it? Until it starts. Until it starts taking back. Yeah. Yeah, when it does that, not a good time. Not a good time. But again, that nutrients that goes in, even in the death and decay and everything else, well, it will go on to make fuel next time round, if anything survives, to, harvest that an X amount of years later. Might not be dinosaurs you'll be putting in a car. That's very morbid, but very true. You ever want to know what dinosaurs smell like? Bit like this. You want to say a bit, it's just not this side of it. Yeah, and oils. You'll make new oil. All of that decaying leaf matter and everything else going into that nice soft stuff. More coal. Interesting. And in that decay, it will also go on for more information, building blocks. Yeah, in the beginning, not great, quite polluted, and that will go on to knock out a few more marine individuals. But bottom feeders always live. That's an interesting thing. But bottom feeders don't stay bottom feeders forever. They evolve. More information, depends on what they're eating, and then, well, life moves from the bracket. What was once here, well, it's going to shift. Next one's up, next one's next dip, next dip. So yeah, water worlds, lovely, beautiful things, but fine art museum. Admire it, appreciate it, but sometimes it's time to go. There'll be one of those events that if it ever happened, say if, it will be called hindsight. If only we knew. What we know now, if only we knew it then. Yeah, but even if you did know it, would you actually act upon it? That's a different question entirely, isn't it? Then who's right, who's wrong? Well, it's not about being who's right and who's wrong. It's who's wise. Because then it changes your behavior, doesn't it? Which it does. It begins to alter your behavior. Because... interesting, very interesting. All depends on how. And sure, a load of landmass, this could explode up and make a nice big piece of landmass for you. But even still, it's going to be maneuvering water out of the way. And especially if it's very hot and incredibly hot. Usually, doesn't that create steam? But if it's underwater, it will condense very quickly. In the cold ocean water, depends on where, temperature. So that in there is not going to be wet. It's going to be dry. When it's going to have to cool down. and then it's going to act like this rice pudding skin.
Okay.
Oh, it's going to get a nice skin on it first. Sure, the water's going to try and get in there, but not in the beginning. Takes time. Be patient. Yes, world and different things like that. Yeah, very much patient. Life forms? Really shouldn't be. That's a very silly word that we use, isn't it? We should all be patient. Not sure. Not sure that's that any humans can afford to be that. Complacent and patient. I think that's not very good. You know, sure, patient for your birthday. Yeah, okay, fair enough. That makes perfect sense, I guess. But patience on a planet where it's in its time. And it's in control of that timing, you know? If you've made all of these apparatus that protect you, could you imagine that? That's another thing, right? Even if this happens overnight, 24 hours, and the whole of your world is completely different. Airplanes don't take off. Ships even struggle to take the copious amount of panic ratio that they're on. You'll understand people will panic in a situation like that. They will try and climb aboard, and too many on a... It sinks. And then everyone's in the water after that. Then, it's where the hell are you going to go? Could you be charting for a very long time trying to find land? Follow the birds. And that's a hell of an amount of mental strength that you need to have. Isn't it, really? And where are you going to go? And what resources? Or what power stations? What food? I mean, Noah's Ark would have to be fucking impressive. It doesn't just need the animals in 2x2s, it needs a seed bank. And again, that's a very interesting thing. What else? It's going to need something to maintain this food growth ratio. Water. You can extract it from the ocean, but then depending on how many people are drinking it and how good is this technology, how long does it last for? Is it going to fail? Do you have enough? Did you remember to bring a toolkit with you? Did you remember to bring spare parts with you? Because there's no factoring. No manufacturers. You know, you can utilize the systems that you have to benefit you, or you can use them to benefit your greed and ego. That's an interesting thing. Those things will get you killed. Mass extinction. Even if a few manage to make it, how long for? Before the next events happen, because then you have taught yourself that you are quite prone to this stuff. Have you taught yourselves to be incredibly silly in those situations? And if you have, where's that brain power coming from? A computer? Well, it's waterlogged. Now you're going to move a server. You're back in the Stone Age. Literally, Stone Age. Worse than the Stone Age. At least they had water and land. Fuel.
And nature.
Nature. Food. I'm sure you could eat ocean fish, but again, you have to go a lot deeper than that. Did you remember to bring nets?
Yeah, and ocean fish they are not as abundant as they once were.
Oh, yeah, because they've been fished
Overfished, yeah. For nonsense.
Oosh. Never a good thing, is it?
No.
Anyway, that's if. Believe what you want, but I can tell you this has already happened on this planet before.
Yeah, it is.
You know it happened in reverse. Large skin of water. Or volcanoes happen to trigger at the exact moment. Wonderful, isn't it? And then create landmass.
Yeah.
Which then we all walk on and take for granted today. And it's almost like, alright, you got this much time. But don't worry, we give you a brain, you can think this shit up, come on. You know, and then it's like, yeah, like that's ever gonna happen. We can fuck that.
Well, it has happened.
It's already happened in reverse. Retro
Yeah.
respect.
Yeah.
And then the more erosion that it is doing the ocean in this process, more debris are falling into that.
Mhm.
More debris means more mass into an already rising sea. Do you see how this
Yeah.
gets really out of hand very
Yeah.
quickly?
Yeah.
When you have to travel to these areas? Oh, the displacement of icebergs. That's interesting. And then no landmass. How reflective is that? How mirrored image is that? Like reflects back a lot of the light.
Yeah, it does, doesn't it?
Oh yeah. And then nature, you're losing the absorption. Mars is very cold, but incredibly warm, considering. Almost a bit too warm. So is there a chemical reaction going off there? Is there some other reaction happening there that is generating a large amount of heat? It's too warm. Way too warm. Odd. Very odd. Strange. Very strange. That's an interesting thing for me. It's too warm. Doesn't make any bloody sense. Yeah, but anyway, then that would be a catastrophic event if it ever happened. And then how long would your ships last in salt?
Who knows?
Well, not very long.
Yeah.
They'd rust through, wouldn't they? You know that everyone thinks that ships don't need land. They do. Sometimes they need to be taken out to be repaired, repainted, treated for too much salt. The salt damages it. Well, I suppose then it wouldn't matter if you were riding around oil slick around you. Interesting. Very interesting. Yeah. See, I'm gonna leave it on there. Just like I said, I'm just clearing out the clutter. I got a few more. Can we go on to another?
Yeah.
This one's done then.